Section 11.3 has a big, long, drawn-out title here, Quadratic Equations with Radical Expressions and Radicals. We're actually going to do two topics in one here today. So hang with me, here we go. What we're going to do first is we're going to solve equations that have radical expressions in them. And that simply means there's fractions. Here we go. So if we've got fractions with variables in the denominators, the steps are going to be like this. Here we go. Step 1, we're going to multiply all the terms by the least common denominator. The reason you do that is to get rid of the fractions. Once the fractions are gone, it's an easy thing to solve. So you're going to multiply by the LCD, and then you're going to distribute and combine the like terms, factor and solve. But then the fourth step is very important. You're going to check the denominators, because if you'll remember, you cannot divide by 0. It's not possible. So if you have a solution that makes one of your denominators equal to 0, then that's an extraneous solution. All right, so let's jump in and actually do it. So step 1, multiply all the terms by the least common denominator. So what you're going to do is look at your denominators. Here we've got a factor of x plus 1. This one doesn't have a denominator, so we don't have to worry about it. This one has a factor of x and a factor of x plus 1. Well, this x plus 1 is the same as this one, so we don't have to multiply it twice, but we do need an x. So we're going to multiply all three terms by x and by x plus 1. So all three terms get multiplied by both of those. The reason you do this is, number 1, you have to multiply all the terms by the same thing in order to keep your equation balanced. All right, once you do that, then you can cancel out anything that is the same in the numerator and denominator of each of these separate fractions. And so if you've multiplied by a common denominator, then all of the fractions should cancel out. There we go. So now you're going to distribute and combine like terms. So now the 3 has to be multiplied by the x. The rest of it was canceled out, so we're just going to have 3x. And that's going to equal 1 times everything is just the x. And what you could do here is actually multiply it out. So you're going to x times x and x times 1. So you've got x squared plus 1x. And then this 3 is multiplied. Well, it's not multiplied by anything because it all canceled out. So just minus 3. All right, so now we're going to combine like terms. We're going to factor and solve. We're going to go back to our factoring days. And remember, in order to factor, we've got to have it set equal to 0. So the x squared term is positive on the right-hand side. So even though it's a little unconventional and we usually have the 0 on the other side, I'm going to keep my x squared term positive. So I'm going to subtract the 3x from both sides. So, and actually, if it's easier for you to put the 0 back over here, remember it's an equation, so you can do that. So we've got x squared minus 2x minus 3 equals 0. And now remember factoring, here we go. X times x is x squared. The signs are different. And 3 times 1 is 3, and we want the bigger one to be negative, so 3 and 1, and that equals 0. So now if you remember, this times this equals 0, so one or the other of them has to equal 0. You remember doing this already? So now x plus 1 equals 0, or x minus 3 equals 0. So subtract 1, so x equals negative 1, or add 3, and x equals 3. Now, it's very important that you go back and check your denominators because, let's see, 3 plus 1 is 4, so that one is fine. And 3 times 3 plus 1 is 4, so 3 times 4 is 12. That's fine. We don't care what those denominators are as long as they are not 0. All right? So now negative 1 plus 1, negative 1 plus 1 is 0. So negative 1 is extraneous. Now here's the deal. I want you to have both of these answers written down. I want you to have extraneous written by the extraneous solutions so that I know you can find both and you know why one is included and one is not. All right? So include both of those in your answers, please. All right. Let's do one more of those and then we'll do some radicals. So The tricky part is just to find the denominator. Once you find the common denominator, now it's just an equation that you know how to solve. So we're going to get rid of the denominator. We've got x minus 4. We've got a 4. And this x squared minus 16, if you'll remember, some of these you might have to factor before you can know what the factors are, all right? But if you'll remember, a perfect square minus a perfect square are conjugates of each other. Remember that word, I hope. So x plus 4, x minus 4, because 4 times 4 is 16, and negative 4 and plus 4 drops out. So those are our factored terms of x squared minus 16. So our common denominator is going to be an x minus 4 times x plus 4. We already have the x minus 4 over here. So we're going to have 4 times x plus 4 times x minus 4. So all of these, 4x plus 4, x minus 4, all of them get multiplied by all of them. Not x, 4. Whoa. 4x plus 4 and x minus 4. All right, so now, it's kind of squished in here, isn't it? So now the x minus 4 will cancel. So I'll just write it all out and we'll distribute in just a minute. So what I have left here is 4 and x plus 4. The 4's will cancel, so what I have left here is plus x plus 4 and x minus 4. And here, the x plus 4's cancel and the x minus 4's cancel, so we have equals 8 times 4. So far, so good? It's complex. You're doing good. Hang in there. So now you've got to distribute this through, so you get 4x plus 4 times 4 is 16. And now if you can remember, x plus 4 and x minus 4, that came from here. You don't even have to work it out again. Go right back up to x squared minus 16, and that equals 8 times 4 is 32. Now combine like terms and put things in the right order so that you can work with it. So the x squared you want to be first. X squared plus 4x plus 16 minus 16 drops out. So that equals 32. Oh, and you know what? We're going to subtract 32 from both sides too. So it's just minus 32 equals 0 because these dropped out. So I just have minus 32. So now factor. So x squared is x times x. 32 is 16 times 2. Oh, we've got a plus and a minus. And so we're going to subtract them to get the 4. Oh, 8 times 4, because 8 minus 4 is 4. And we want the bigger one to be positive, so 8 and 4. And then check it again just to be sure. Positive 8, negative 4 multiplied is 32. 8x minus 4x is positive 4x. Oh, we're good to go. So set both equal to 0 now. X plus 8 equals 0, or x minus 4 equals 0. Subtract 8, so x equals negative 8. Or add 4, x equals 4. Now, before you circle them both, don't forget, check your denominators. So x is negative 8. Negative 8 minus 4 is 8, 9, 10, 11, is negative 12. This one doesn't matter. Doesn't matter what x is. 4 is going to be 4. 8 squared, 8 times 8 is 64. 64 minus 16, I'm not sure, but it's not 0. All right? You can even do it like that. 4 minus, guess what? 4 minus 4 is 0. You don't even have to check the other one. 4 minus 4 is 0, so 4 is extraneous. And negative 8 is our only solution there.